everyone. After class today, I got thinking a little bit about the concept of people understanding or not understanding exactly what mathematics is when you are doing algebra or anything else. And the fact that some of us comprehend well in 2 dimensions, some in 3 dimensions, but we all comprehend somewhat well in 4 dimensions. Otherwise, we couldn't cross the street. We couldn't catch a ball. And this is one of my kind of true core beliefs that, in effect, we do get some of the math when it's the true math, which is what is around us. But when we, as engineers, scientists, and mathematicians, codify it, it can make it more confusing. So, albeit we have to realize that we all occupy space in X, Y, and Z, northings, eastings, and elevation, or occupy space and a particular space at a particular time, we have to realize that, therefore, our position in the X, Y, and Z locations are functions of time. Heretofore, before Justin Timberlake and Peyton Manning started with that commercial, before Avatar, and before all the gaming stuff that's out here, we really did limit ourselves to 2 dimensions with a lot of this math, and we'll continue to do so. So let me start here by introducing to one of the math programs that I just went gaga about in the last 2 years as I thought about how great it will be for my kids when they hit junior high or high school. And let you know the price point on this was probably around 15 bucks. Now, I'm not telling people to go out and buy it, but as I talked about Windows software that would do things similar to what the Grapher software on Apple does, this is one that comes to mind. And so I'm just going to introduce you really quickly in these 10 minutes to this idea of Geometer Sketchpad and what it can do. I will be clicking here and around and probably messing up a little bit. It's been a while since I've been on this, but immediately what I'm going to do, like we talk about in all problem solving, is I'm going to define a coordinate system. So I've just defined my coordinate system. In this program, we can, if you notice, the scale is about equal in and out on that screen, so I can really kind of go in and out and make that coordinate system a little bit better. And I can do a couple of things in this program. I can actually draw and then ask it the equation, or I can write the equation and then draw it. So let me do what we talked about in terms of the circle today. Some people may have a hard time realizing that if I grab the circle here and I pull across here, then in effect, and this is what I did in class 25, right around there, basically that is a circle. And it looks like a circle because my axes are equally divided. So this is 15 and 15, so it's going to look like a circle. But hang on one sec. Okay, what I love about this program is I can grab on something and then give the equation. So you remember I talked about the equation x squared plus y squared equaling r squared. Once I've got it drafted in a program like this, I can grab the circle. I guess I can't. I can grab that circle and I can take it and show how the equation responds to it. And I think I can even grab the equation. I guess I can't do that. And have it draw it. So I can now do all this, draft, number. I can do a new function. Now the problem with the new function is it doesn't always work. F of x equals x. Let me go back here. 5x plus 6. Now many of you will recognize this as I start talking about a line, y equals mx plus b. When I graph that, you'll see that line. Plot the function. Now in this case, you can see that it goes through the point 6 and it has a slope that's steeper than 45. So if I go to here and I make that 1x, remember something that is in a 45-degree angle has a slope of 1. You get that. And if I take it down to 0, you see that concept of the 45-degree line. So a program like this makes it possible for you to actually play around and see some of what you're going to be doing in algebra or in all mathematics, analytic geometry, and it's got a pretty low price if you use your kid's logon or your kid's name. So this programmer is called Geometer Sketchpad. It's got hooks, and it's, you know, I learn, I forget, but it's got a lot of really great value to it in terms of dealing with two-dimensional math. Now, it's not a three-dimensional program, but you start in 2D, you work your way into 3D, though you have to recognize that at the same time 3D is coming fast at you from the way the world is starting to work. So let's see if we can now do one more line. We can now go to here, and we can go measure, we can go number, we can go new function, and now we can have the value equals maybe, let's see, maybe a minus 6x minus 9. And we can hit OK there. And then we can go to here and hit right click and plot the function. And we get, in effect, that other line. And what eventually you will see is that f of x is more or less y equals x plus 0. 1x plus 0 is a 45-degree line. G of x equals minus 6x minus 9 means that it crosses the y-axis at 9 and it's down steeper than 45 degrees because the absolute value of that number there is more than 1. If it's negative, the line goes down, and if it is positive, the line goes up. If you get so much as something like this, once again, number, new function, y equals 2, and you hit right click, plot function, you get that next line. So this kind of gives you that ability, I'll do one more, that ability to realize that mathematics can be expressed by formulas or by shapes, and it is the same thing. Now we'll get to this concept in a conceptual way when we start talking about something being influenced by something else. In our case, the equation will be the shear strength of soil as a function of how much something is pushing down on it. Now in this second week we've done some kind of fun or crazy or interesting applying of forces and using leverage and simple machines to subject a soil anchor to a tensile force causing shear through not only the soil, which did not fail, but also through the metal, which started to actually yield. All these things are eventually expressed mathematically, and understanding very quickly that usually it's not y versus x as you see in survey. It is something like strength versus depth, or speed versus power, or retention versus detention when we talk about stormwater. So something is a function of something else, with usually the x-axis being the independent axis and the y-axis being the dependent axis. In other words, changes in x cause changes in y's, and that's what you see in this format here. So we'll finish this out right now with drawing a couple of different shapes and then showing you how these things start to be animated. So once again, I am going to draw a circle here, and that equation of that circle, and a circle there. And now I'm going to draw a line. Let's see if I can do that. I'm going to grab this and this, and I'm going to construct points on circles, which I don't really know, and I'm going to draw a line from that point to that point. And finally, I'm going to take that right here and say measure, and you see it just gives me the slope here. I'm going to put that off on the side. It won't give me the equation of a line segment. And let's watch what happens. Remember, see how that's negative there? Watch what happens as I take D and I animate the point. See, it's positive. And so the slope describes basically the slope of the line, with it going from 0 on a line that is horizontal to positive infinity if it's straight up, or negative infinity if it's straight down. A negative number means it slopes down from left to right, and a positive number means it slopes up from left to right. So there's a lot of software I'm throwing out there for you right now so that we can keep everyone, if you've had mathematical skills or not, you're going to see one of these programs, something, and a combination thereof, and the great instruction here at Midstate is going to get you to the point where you can early apply your mathematics or the logic of geometry and math to engineering solutions like pulling soil anchors out of the ground, or starting to solve some of the transportation problems that face the planet. So the program is called Geometer Sketchpad, and I will provide a couple of interesting links that will tie you back to its very, very beginnings. Thanks for listening.